Today, we're going to talk about why psychedelics alter our perception of reality and what that says about reality. On the last episode of our show, we talked with Stanford anesthesiologist and psychedelics researcher Boris Heifets about the question of why psychedelics help people with mental health disorders. Boris told us about an experiment where he gave ketamine to patients with depression while these patients were under general anesthesia. This was intended to be a clever way of accounting for the placebo effect. Only half of the subjects actually got ketamine. But his results were extremely surprising. Patients in both groups got better. It's worth checking out the last episode to hear the whole story. Today, we're going to dive into a different question, which is to explore how psychedelics work in the brain. How are they able to alter something as fundamental as our perceptions of reality? And could understanding these effects teach us about the nature of our everyday perceptions? This is From Our Neurons to Yours, from the Tsai Neurosciences Institute at Stanford University, bringing you to the frontiers of brain science. We're going to get into some brain chemistry and circuits and anatomy and all of that, but as usual, I wanted to make sure we're all on the same page about what we even mean when we say psychedelics. People get confused about this term. What makes something a psychedelic? Obviously, acid and magic mushrooms are psychedelics, but what about ketamine or ecstasy? That's how Boris and I started this conversation.
You jumped right into one of the stickiest points. What is a psychedelic, right? And we actually have done a survey on this. We've surveyed almost 1,000 people now. It's a media survey where we're trying to understand, where do people find out about psychedelics and what do they think psychedelics are? Everyone seems to think LSD is a psychedelic. Check. And the same number of people, about half, think that ketamine is a psychedelic and MDMA. Fortunately, very few people think methamphetamine is a psychedelic.
Very good.
And but we can at least draw some bounds. So why is it that there's this sort of wishy-washy, maybe ketamine is, maybe it isn't, maybe MDMA is? The fundamental issue is that, well, first of all, for people who've taken a classical psychedelic like LSD or psilocybin, the experience is unique and unmistakable. It's, alterations in perception, vision. The best way I've thought of to kind of explain it to someone who's never taken it is, when you say a word over and over to yourself until it loses meaning, or start looking at a body part and be like, why does everyone have noses? And it just gets really weird all of a sudden, right? It's sort of like that, but with everything.
Wow.
In domains of vision, emotion, even the paranoia that can feed on itself, all of these things are possible. Feelings of unity and oneness, these are really characteristic of those classical psychedelics.
Is there a sense in which it's everything becoming unfamiliar?
I don't know that, or everything becoming new again, or I never looked at it that way before, perspective taking, you'll hear people say that a lot, or saying things that are honestly sound like Hallmark cards, love is everywhere. My children would shoot me if I, said that to them with a straight face. But honestly, in the throes of psychedelic experience, you appreciate that in a way that maybe you never have before. And the words take on new meaning.
But it's not just an intellectual thing, it's also the sensory experience is transformed as well.
And it's an emotional experience. It can be euphoric, but let's, separate that, for example, from drugs like cocaine, where it's pretty much like a one-way street. Pretty much everybody enjoys it to some extent.
Right. It's all euphoria.
It's all euphoria. And, drugs like psilocybin, again, the active ingredient, magic mushrooms, people don't abuse it, right? They don't engender that euphoria just automatically, that they can be profoundly disorienting. We think that they're very context dependent, and the experience of taking psilocybin in a therapist's office is very different from taking it at Coachella, for example, right? Different aspects of the experience are amplified in different ways. Again, to contrast that, so why do we even bother grouping it together with drugs like MDMA, which don't have that same degree of perceptual alteration? It's very much emotional, that safety, feeling like you can talk about painful memories, connecting with other people, or ketamine, where you dissociate from your body. Some people say it allows them to take a perspective on themselves. What I'm getting at is that these are all non-ordinary states of consciousness, right? And they clearly have different qualities, but they also share this property of you get some distance from normal waking life in a way that in the right context can be therapeutic. They allow you to take some perspective on your own situation, on who you are, how you relate to the world. That is really, if you want to think about these as a broad group, drugs with different qualities of effects like MDMA, psilocybin, ketamine, the thing they have in common is they're all profoundly psychoactive. We think that psychoactive effect is important for change, transformation, wellness, insight, creativity, and the effects seem to last beyond them being in your body, right? Long after the psilocybin is cleared, you can still feel the after effects, right? You still may take that change perspective with you. And that idea, the fact that you can have a life-changing experience. I'll just give you a quick example. One of the earliest studies of the modern era, the 21st century, with psilocybin was in end of life, people with terminal cancer diagnoses. And what they found is it didn't change their lifespan, but it gave them a fundamentally new perspective on their life and their death, and gave them some closure and allowed them to reduce some of that anxiety about death. So again, all of that is to say that this idea of like getting outside of your normal stream of consciousness, getting some perspective on who you are, where you are, and how do you relate to yourself and other people, that's important. We think that's important.
In that case, that's sort of the commonality that you're drawing out, but maybe they're doing it in pretty significantly different ways. MDMA is acting on, say, empathy circuits. Ketamine is doing something to our sort of embodiment of consciousness, of feeling in our bodies rather than dissociated, whereas classical psychedelics are doing something that's more sensory and all-enveloping. So maybe we should dive into talking about the classical psychedelics, because the thing I'd love to try to understand here is there's been a lot of talk of psychedelics as a therapeutic, which we talked about the last time we spoke. But I'm interested in asking, what are they teaching us sort of about our perception of reality? Because to me, it seems like the fact that this chemical can alter the nature of our perceptions calls into question the nature of our perceptions. What are those? How are our brains constructing those? Do you see psychedelics as a potent way of investigating that kind of question?
So strangely, not particularly. I think actually in that I don't know that psychedelics can tell us as much about consciousness as we'd like to know. What is the quality of red? Like, how do you transmit what an ice cream cone tastes like to another person? If anything, actually, it's that question that you just asked it calls into question our normal waking consciousness. If you can get to that point, right, questioning your own assumptions about reality, how many other things can you question? Like, should I leave this terrible relationship? Should I pursue this opportunity that I was putting off? Should I take this risk? That is really the process. You can get there by a number of ways. Now, I've dodged your question already, but I'm going to redirect it a little bit in that I laid out the case for lumping psychedelics as a broad class. Now I want to split them, as you said. Like, they each do actually have different properties. And that is the heart of ongoing investigation, right? We can break this down into component processes. So, for example, people have been very interested in cognitive flexibility, your ability to learn new rules quickly in shifting circumstances under the influence of classic psychedelics. We've been studying social approach with MDMA, that is like a basic behavior that you can study across species, from mice to humans. Empathy, again, something that's more related to MDMA and entactogens. You can look at each of these component processes that are influenced by these different drugs and then really start to drill down into mechanisms. Now, I have to say we have not gotten very far with the classic psychedelics. What we do know about the classic psychedelics is that, we see that the neurons grow these connections. New synaptic connections, we believe, are formed after exposure to a psychedelic. And we also see some behavioral changes in humans. We can look at things like cognitive flexibility, reinforcement learning, reactivity to faces, like threatening faces, fearful faces or happy faces. Like, the real question is, like, can we connect those two things up, right? We have these structural changes in the brain, where we have new dendrites form, and we have these behavioral changes in humans. So it's a long road to put that together, and I'm just going to paint a picture of how people are trying to do it.
May I ask quickly, how well would you say we understand the mechanisms of psychedelics as compared to opiates, alcohol, THC, other drugs that we've been studying maybe for a longer time?
I mean, opiates is probably the best example of a drug that is pretty well understood. There's always more to uncover, but it has many effects: respiratory depression, analgesia, euphoria. And we've been able to isolate, again, breaking it down into component pieces. Each of those is mediated through different circuits. Some are in the spinal cord, some are even in the periphery, and certainly opioid receptors in the brain itself. Each of them contributing to all of the different facets of opioids, both the good and the bad.
Got it. And so this is what we're now trying to do with classical psychedelics, let's say.
And now think about something like respiratory depression, right? This is what overdose is with an opioid. That's actually pretty easy to get an animal model of respiratory depression, right? It's terrifying, but it's well conserved.
Right.
Now, we have a little bit of a different problem with psychedelics. How are you going to mimic, something we can still barely measure in a human? Cognitive flexibility is like a pretty loose, it's not a loose concept, actually. It's a pretty well-defined concept, but...
Right. How do you know if a mouse is reevaluating the nature of existence?
Yeah. So there are ways to get at that. Like, at the very least, you can ask, is the mouse able to learn a new pattern more quickly? And there's some evidence that at least rats can do that a little bit better under the influence of psilocybin. But these are hard studies. And, I'm going to be very critical for a minute. And that a lot of the excitement in mouse neuroscience, which is where I live a lot of the time, is around, we take the thing that we have measured in humans and measured a lot, which is depression, a mood. And we've measured that in humans, and psilocybin seems to make mood better. Now, when we do that in a mouse, we run into all kinds of trouble. That what is mood in a mouse? Have we discovered anything in mice that has, as a result of that basic science, that's made the leap back into humans? We have, actually. There are success stories in this area, but they are few. And the way that we test for these things in mice is pretty controversial. And that how much does something like learned helplessness in a mouse, where, when do they give up swimming? Is that the same as learned helplessness in a human? Many people would argue that it's not. You can't translate something, 3 pounds of brain down to, a few grams of brain without losing something in translation, right? So this is a very long way of saying that most of the excitement has been around trying to answer the question of how do psychedelics like psilocybin promote an antidepressant effect. We see a lot of changes that are associated with psilocybin. We see neurons firing across the cortex. We see dendrites blooming in cortical neurons. We see, some new behaviors emerge, like sensitivity to social reward, for example. It's from Goldolan's lab. We see some changes in cognitive flexibility. Which of those actually relate to the antidepressant effect is very difficult to establish here. I can sort of paint you a picture of how we get from one to the other, but there are a lot of missing links that we need to fill in before we can say that what we're looking at in a mouse represents what people are experiencing.
I'm interested in turning this back to the question of perception, particularly with LSD and psilocybin and other classical psychedelics. The reports that you hear from people are about the perception of reality. We talked about this a little bit at the beginning. And on the one hand, that seems like maybe something that's a little bit easier to test in a mouse, maybe not, than mood or cognitive flexibility. You've written about this idea of outside in versus inside out experience. And I wonder if that's something that could help us understand the questions that we're asking, even if we don't have answers yet, about how these compounds are changing the way that we perceive reality.
Nick, I have some bad news for you. I only have questions. I have very few
That's great.
answers.
We love questions.
So let me illustrate some of the difficulty. I'm going to tell you a story about an experiment we did, which sounds really simple and led us down a total rabbit hole into what is a mouse actually experiencing? You have to ask that question at some point.
Great. I'm ready for this rabbit hole.
So, I told you in the last episode how we did this experiment. Patients were getting general anesthesia and we gave them ketamine.
Right.
It was, interesting study. Everyone got better. That led us to reevaluate like maybe how we might do the next study. We really are interested in doing this with psilocybin, right? What happens when you take the trip away from psilocybin? So let's, give people psilocybin under anesthesia. Sounds great, except no one's done it before. So we want to figure out some of the kinks in mice first.
Sure.
And it started as a very kind of garden variety basic science. Like we anesthetize mice, we give them psilocybin, we measure how long it lasts, we make sure that it's reaching the receptor under anesthesia, like cool. Then we start looking at brain activity. And our thought was like, we're going to have a problem because anesthesia shuts the brain down, right? Like that's what happens. First problem. And like, so it's just going to shut down psilocybin evoked activity. And this experiment is not even going to make any sense, right? There's no activity, like nothing is happening. So how do you even know what you've done? And so I was thinking, well, let's just see how bad it is. And we did some EEG in mice. The first thing that was weird is like everything is a lot clearer when they're anesthetized. It's as if like you silence the room and now you can hear a pin drop, right? And that pin, it's not a pin, it's a psychedelic. Like it looks like there's, very visible changes under anesthesia with psilocybin.
Interesting. So you're seeing it even more clearly.
We're seeing it even more clearly. And that's a relatively simple and crude measure. We did something a little bit fancier where we actually imaged the entire mouse brain at once, looking at a marker of recent neural activity. This is a technique that's been developed, at Stanford and other places that we stand on the shoulder of giants as usual, but we're able to look at brain-wide neural activity. We've done this before with psilocybin. The brain is on fire. No surprise.
Right.
Then we did it under anesthesia. The brain is on fire. Actually, it's even more widespread, like this activity of when you give mice a psychedelic under anesthesia. And this is a big WTF moment. And my first thought was like, you guys screwed it up. Like you didn't turn on the anesthetic. Like you're kind of trolling me. These mice are unresponsive, by the way. Like nothing is getting in, but something is going on. Okay. So no, the anesthesia was on. We did all the post hoc analysis. So what is that? Is that an experience? Is the mouse having an experience under anesthesia induced by a psychedelic? We will never get an answer to that question from the mouse.
Right. Unfortunately.
But this links up to something we talked about in the last segment, which is dreaming, right? So particularly dreaming during emergence from anesthesia. In the course of doing all of these studies, we noticed that, the signature, this EEG signature that we see when mice get a psychedelic under anesthesia is very similar to that EEG signature we see when patients are right on the cusp of awakening, right? It's like a kind of evanescent state of consciousness that has not been well described that people they definitely, like we put them in that state and then it is associated with them saying that was more real than reality.
Wow.
And, I dreamt I was in Italy, I could taste the pasta bolognese.
Wow.
So it kind of gets us thinking. So I want to just go back to this poor mouse. This poor mouse who's like flat on his back, who's clearly tripping, but not moving, right? Okay. It doesn't respond to tail pitch.
Right.
This is not like I'm more sensitive to the external environment. There's a widely held belief, something called the entropic brain hypothesis. This is put forward by Robin Carhart-Harris, Carl Friston. And it boils down to the idea that you have ingrained patterns of thought that you don't really change by getting more sensory input. But under psychedelics, you raise the temperature, everything gets jumbled about, and now suddenly, instead of these priors being projected onto reality, you have all of this input now is able to reorganize, your patterns of thought.
Interesting. So instead of relying on sort of assumptions or you said priors, but you mean like your beliefs about what is likely to be there, right? I often think about this in terms of the phenomenon that I think most people have experienced of like sitting on a bus and looking at the person next to you and realizing that you had this whole picture in your mind of what that person looked like. And when you actually look at them, you realize that they don't look like that at all. Is that the kind of priors you're talking about that your brain is putting out in reality?
That's beautiful. Yeah. So that this is like implicit association tests looking for sexism, racism, things like that, where you can measure these things. People project priors onto reality. And can you destabilize those priors and make them more sensitive to new input?
Okay, and that's the entropic brain hypothesis?
Yeah. So let's get back to this mouse. This poor mouse on his back who's not hearing or seeing anything, not feeling anything, but clearly tripping. If what I'm saying is true, and again, there's some steps to establish it, there is no sensory input that's coming in, right? It's not a bottom-up idea of psychedelics. It is very much an inside-out, right? This is an internally generated experience. And if you want to think about it in terms of priors, it's not destabilizing priors. It is all priors.
Oh, interesting. Right? It's all the person who you're imagining sitting next to you. There's nothing about them.
That's the only thing that exists. So I'm going to, again, go into a fact-free zone for a minute. One way to look at this is that this is, what we're edging towards is a way to experimentally isolate a context-free psychedelic effect. When you limit external sensory input, the psychedelic gets even more psychedelic, to be determined in human studies. This is a way where you can start to parse out, is it the drug? Is it the trip? What's the role of context? What's the role of, things going into the trip? Does it matter what music playlist you're listening to? These are empirically answerable questions with these tools. Engineering altered states of consciousness in a very intentional way can actually get at some of these very difficult questions. So I don't know the answer, but the experiments that I've just described, and our poor mouse, it's gotten a lot of airplay, but that leads us to some different conclusions than some of the kind of dominant theories about how psychedelics work.
That's very interesting, and it sort of goes back to this idea of inside out versus outside in. Are psychedelics changing the way that your brain interprets external stimuli, or is it creating a dreamlike state in the waking world, essentially, where some of the things that your brain is internally generating start to compete with what's going on in the outside world, with the senses that are coming in?
Well, you can talk to some psychonauts, and I'm sure they'll have very informed opinions on, which of those. Again, these are hard questions, and I would reiterate, we don't have answers, and this is where the data is taking us, right? It's not enough to say the drugs work, don't mess with it, right? Legalize everything. It's important to try and deconstruct this pretty complex process, and we're actually learning something I think that's pretty interesting and compelling, and may actually allow us to innovate on this raw power that we see in psychedelic medicine.
Well, thanks so much, Boris, for coming on the show again. This has been a fascinating conversation, as usual.
Likewise. Thanks for having me. This is taking us to some fun places.
Absolutely. Thanks again to our guest, Boris Heifets. We'll include links for you to learn more about his work in the show notes. If you're enjoying the show, please subscribe and share with your friends. It helps us grow as a show and bring more listeners to the frontiers of neuroscience. We'd also love to hear from you. Tell us what you love about the show or what you hate, or share your suggestions about the next frontier of neuroscience for us to explore. You can reach us on social media at Stanford Brain. From Our Neurons to Yours is produced by Michael Osborne at 14th Street Studios with production assistance by Morgan Honaker. I'm Nicholas Weiler at Stanford's Tsai Neurosciences Institute. We'll see you next time.